Ladies and gentlemen, I would like to welcome you on this session, Multimedia Support for Communities. My name is Bartłomiej Dziekowski. I am from Poznań Supercomputing and Networking Center from Poznań, Poland. This session concerns different approaches for assisting the societies, basing on modern multimedia solutions, and it presents efforts of the communities for popularizing new technologies. There are 3 presentations within these sessions about EVO by Philippe Galvez, about high-speed photonic network usage for very high-quality media by Michał Krysek, and the third one about Cinegrid Amsterdam by Frank Kressing. There are also, at the beginning, 3 announcements from Tirana. Please remember about demonstrations during the breaks. They are in Zenit, in this room, and in Taiko rooms. The poster presenters will be available between 3:30 and 4 p.m. today and also tomorrow. And please remember that there are extra events in the evening, the booths and workshops. Okay, so let's start the presentation. I would like to invite Philippe Galvez, who is a senior research manager on the California Institute of Technology, and he will tell us about EVO, from EVO to CVOT. Please.
Thank you. Okay, I guess my microphone is working fine. So, good afternoon. Thank you for inviting me to this talk. So, as has been mentioned, I've been working at Caltech for the last 15 years, working on collaborations and multimedia. And basically, my main focus was to try to provide some networking and collaborating feature for the LHC at CERN. As most of you know, the Large Hadron Colliders, which is involving a lot of experiments. So what I will try to describe during this talk, it's descriptions of what has been developed the last 15 years, and some of you probably know the EVO, Collaboration Services, the one which is in productions. Some slide about integration and standards, because obviously that's very important, is the compatibility with other devices and other applications. Speaking about additional functionalities, which I believe are critical, especially for the worldwide communities, and some word and for how to access this technology, because it's most of the time one of the main questions is to say, well, that's great, how can I get it? And that's some slide about the commercializations of this. Okay, so the EVO services, basically, as I said before, has been developed and designed for the LHC experiment, physics experiment, worldwide dispersed. Several thousand of physicists need to collaborate. We need to find a tool. And what we basically did, we did develop a tool in a worldwide scale. And the main requirement for the physicist is to be able to collaborate on a different range of environments, such as a laptop, conference rooms, control rooms, and they have to have the same tool to be able to interconnect each of the different devices. And as we can understand, that by doing that, we build and operate a system that can support the entire research and communities on a global scale. So basically, the EVO services went beyond the LHC services or LHC communities as has been initially designed. Some parameters which was very important is that when we try to address or offer services for several 10,000 of users, we have to design a systems which in fact can contain the operational and user support, because that's very important. You don't want to have an exponential growth when you provide such services. Some keyword about the service itself, and I don't want to go too much in technical detail there, and I will be happy to discuss later on that. So basically, EVO, it's available in 12 languages. We can deal with all the different time zones, because this is, again, a worldwide services. It works on all the OS, Windows, Mac, and Linux. It can interoperate with any standards, H323, MCU client, SIP clients, IP telephones, and even Skype. Can do both unicast, multicast, for those which are familiar with that. And in terms of video standards, it can go up to 1080p resolutions. So here you can see a wide range of capabilities that the system can provide it. Concerning video codec, or the well-known codec H261, 63, 64 are supported. Another very important part was the integration with standard-based web authentications. So it has been integrated with Indigo, for those who knows it's a booking systems that has been developed by the European project, and it's running on many research institutions. We did integrate Shibboleth authentications as well, and which means that the end users using the own credential can access the services using the same login and password of the institute. Some numbers about the services itself. We have around 2,500 sites connected to meetings every day. That involve around 500 international meetings. Some meetings involve themselves around 200 sites, even more, on the same meetings. And at a given time, we have some peak actually of 850 sites connected in the same system. So you can see, you can have a guess about the load of the current system as it is now. Let's see. Here it is. This is the current architectures that has been developed. So on the top, let me see if I can work here. So basically, as we all know, we have these centralized systems, which is as it is developed here, where you have an MCU and everybody call to this particular point. And if this MCU is going down or have a networking problem, everybody is disconnected, and that's a big difficulty. And you add the difficulties if you want to start to cascade MCUs. So what we did develop here is the peer-to-peer servers, but on the server level and not on the client level, as you can see for some applications such as Skype. So we did develop and deployed different servers all over the world. Actually, we have around 70 servers, and all of them are in a peer-to-peer environment. So which means that if any of these, for some reasons, get disconnected, have an issue about networking, then automatically the topology will respond to on the fly. From a client's perspective, what we have here is that the client will automatically connect to one of the servers transparently from the end users. And again, if one is down, it will automatically connect to another one. Which means that in any case, if there is any issue on the networking layers, it would take no more than 10 to 20 seconds as interruptions for the end users to get reconnected and still participate to the meetings. That are monitoring services. So as you can see here as well, this is a worldwide view of all the servers, which are the blue bubble here, and they are constantly monitoring each other to provide this real-time peer-to-peer environments. And this is a GUI that allows us to monitor all the meetings. This is the interface that we are having, we did build, and we are as well modifying and announcing every time this part. So you can see the list of meetings here, the different participants with an IM type GUI, different chat that you can participate. And when you enter to the meetings, you have different functions, such as typical one, microphone, speakers, and different things. So some more about the integrations to make it kind of clear what it is. We do work with H323, so we can connect to any H323 endpoint or MCUs. We do online transcodings. We work with gatekeepers and are compatible with firewall. We do provide interconnection with the telephone systems, so you can connect and use any of these phones to connect to any meetings on the fly. It's relatively easy to add any new phone. We just need a SIP gateway somewhere. So we are working with a lot of institutes which already have a SIP infrastructure deployed, and we just add the phone numbers. And it just takes, if not a few minutes, to add a new phone. This is some snapshot about how you can use Skype as well. So we have a evo.phone Skype users. Everybody can use, call these numbers, and access to the meeting with your Skype. This is a snapshot about the Shibboleth integrations. So as you can see here, so you just authenticate yourself. As soon as you authenticate, you see the list of meetings that belong to your communities. And you just have to click on one link, and you're in the meetings and already identified with your name and your access. So that's a web portal. So some additional features and functionalities. We do provide as well recording and playback functionalities, which means that every user can record and playback any meetings of any type. So when they do it, they just, when they want to record, they go with this interface, they specify the names, and they just record the entire meetings. Or the recording will be done on the machines, on the user machines. And so they have all the flexibility to do anything they want with that. On the playback environment, that they can already play back and recorded meetings. And one piece which is interesting as well is that they can play back to a meeting which has been recorded to a live meeting. So they can mix both playback and live meeting to discuss on some particular contents. Just recently, we do provide the transcoding functionalities, because one of the challenges when we do an Evo recording is that we have multiple video, and most of the standard way to record a meeting is only to use one video. So we do provide a converter that converts any Evo recording or any standard type format that people can put on the web and distribute. This is some snapshot about the transcoding, that software transcoding that we did develop as well. And we can select any type of layout. This is just a snapshot of possible layout. And we can do much more, let's say, as request or as needed, if it makes sense. So we have a full control of all the video and the way we want to present them. That's an interesting feature too, which is heavily used, in fact, which is a shared desktop. We can take any part of the screens or the full screen if needed and send it to the video. Oops. And send it to the remote participants as a video. So what is very interesting here is that we can go up to the size resolution of the screen. So we can go up to 1916 if it's needed, and everything will be sent and transmitted to the remote site. So we can have a very clear resolutions, and that's very important when you do graphics and pictures. That's our very important component, which is a video functionality. So we do develop a video component which is fully based on OpenGL. So basically what we do, let's go back here. What we do is to incorporate the display into an OpenGL framework, which means that everything which is received and recorded and display will be done within this OpenGL windows. And that allows us to use different type of, or to leverage GPU mainly to do renderings and to provide some 3D effects like shadows within the GUI itself. This is another snapshot about how it looks like. So you get to see the different video which has been received, and you can browse in any of them. And all of that, obviously, it's real time. We do work as well on some interesting additional pieces on the video side, which is, as you can see here, we can send multiple cameras on the same meeting. So instead of sending one video, which is most of the time what usual applications are doing, is that we can send as much as camera you have connected to your computers. So here, just connect 4 USB camera, and you can send that in real time at any formats. And that's very good when you want to create an immersive environment. We can as well take this 4 video and create a unique video here. And that's another example here, which what you can see here, it's a unique video which is resolutions. So you can create panoramic video using multiple camera and encompass that on the unique video stream that will be received by the remote site. So, and that you could provide some different functionalities. We are spending a fair amount of time as well to try to develop what we so-called a telepresence environments. And for doing that, we did develop a unique H.264 codec, fully compatible with a standard-based codec. But our H.264 codec is fully multi-threaded. So by doing this design and by implementing the code, what we did manage to reach is that you can have a system such as this, and we are able to send and receive more than 3 1080p video, encode and decode, and so using unique PCs with one unique CPUs, all because we are leveraging the multi-threaded environments. So which makes such a development and deployment highly affordable for anyone that wants to develop in a telepresence environment. So what you just need in this case, you just need to buy a 4 screen, one for the control and data, 3 HD camera, which is costing less than $1,000, commodity PCs, a few $1,000s, and you already have your telepresence environment, again, capable of sending and receive more than 1080p video codec on both sides. So that gives you a kind of overview about the system itself and all the capabilities. Obviously, we can speak much more about that, but I just wanted to give you a kind of feeling what is Evo and how it is used as of today. You know, the other key point is that how this technology can be made available to the communities at large. To do that, we had to move from an academic sphere to commercial entities. So via the California Institute of Technologies, they did create a spin-off companies, which is called CIVO, which has its headquarters in Pasadena, and which then are able to provide these technologies on a much more, let's say, support and coherent approach. We have already some customers around, basically universities and different institutes. And here's a philosophy which is reached because of this technology that we try to accommodate within these private entities, is that we all know that at the end, the cost of video conferencing itself will be zero. I mean, everybody is using video conference, and we will reach this $0 sometime pretty soon. We all know as well, especially on the research and academic communities, that we have everything which is better, faster, cheaper, more bandwidth, or unlimited bandwidth. And the only way to scale that's a no-brainer is to have everything in software. So we do believe that using these technologies, in fact, the key approach is that group video collaboration will be the social applications as we go forward, and the cost will be likely close to zero. So using this approach, we start to get two different type of product based on the requirement which has been provided by us, by the universities. One is called the CIVO Campus, that allows teachers and students to be able to use this technology to do classrooms. Another one is CIVO Cloud, which is something I will develop a little bit later. So for the CIVO Campus, basically what we did, we integrate this technology, and we provide a customized interface, in fact, where the students or the professors can organize classrooms via a web portal and include the different students to be able to participate in these classrooms. So basically, when the student arrives, he has this particular interface where he just obviously follow the courses, but he can click on the raise hand, which pop up a window on the teacher's desktop, and if the teachers authorize the student to speak, then automatically his microphone and speaker will be enabled, and different type of actions in this line. But it's much more to try to simulate a classroom environment. What is very important in this particular deployment is that it's fully integrated with the university portal. So nobody has to register. Everything is managed by their own database. So a student which is already registered in the university just have to log in with his usual names, and he will see the classroom, the virtual classroom that he has been invited to be, and he just have to click and join. The CIVO Cloud, that's another interesting development using this technology. So because we are purely software, so we are capable of running the different servers on the cloud. We have made a lot of experiments and a lot of successful experiments, and which, in fact, we will leverage any cloud, either public or private, which are theirs, and create servers on the fly as request on demand. This worked pretty well. And that will allow us to have or to be able to offer to any groups, individuals, or institute a way to organize communities and group meetings on the fly at a very cheap price, in fact. Because, in fact, the infrastructure will be built on request and do not have to be deployed before. Some current case, just give you some ideas. So actually, the CIVO Campus product is deployed and used at University of Paris 6, UPMC, They did an official launch a few months ago, and they have no virtual classroom between all the different campus and groups. Another usage is, for example, here again, it's a SunSpec Alliance, which is an alliance grouping all the different manufacturers of solar energies, and they did use the technologies to make some large inauguration events the last few weeks. Another one here is HOT. It is, again, another initiative which is using our technologies. So basically here the intent is to do online editing on the fly. So you do an interview with some people around, and automatically the system will edit the content and provide the output with the full edited versions of this interview on the fly in a very customized manners. So all of these three cases, for example, show you the different use of the technologies. And here the key point to remember is that, again, the video is not the one that you have to pay, because the video is free. What do you do with it? It's a content that you will have to monetize in one sense. This is some reference points for those that want to have more information and contact us. And there is many additional slides, but I don't think I will go over that. I just prefer to give more space for questions, if any. That will be all. Thank you.
Hi. Thank you for a very interesting presentation. It's very interesting to see the different versions of Evo that you've created for different use cases. So I'd be interested to learn more about that. But I wonder if now you could say a little bit more about how you integrate Skype into calls.
So yeah, so the Skype gateway is basically what we did install some servers which are provided by some companies, which allow SIP integrations. So we are using third parties to make a SIP call, which then integrate with Skype. And we have actually two servers doing in this way. The main challenge with Skype is that, and I forgot to mention it here, is that it's the video part. So what we do provide up for now, it's only the audio. Having the video, which is extremely CPU intensive if you really want to do the conversion, and if you really want to offer that on a large scale, because I'm not meaning to send it to, or to provide it to 2 or 3 concurrent nodes, it has to be potentially for a few hundred. That will be the main challenge as for now.
Thank you.
Do you plan to support 3D video conferencing as well, maybe using multiple HD streams? Or?
Yes, we do, and we already start. So it's already done. I didn't show it here. So in fact, we do 3D video conf. And I should probably put a slide there. In 3 different ways, with a typical blue and red formats, where you can put your glasses, and it's worked pretty well, so we do integrate that. We are working as well with the NVIDIA 3D visions. That's another way to support the graphic card to do it. And the last, in fact, we did integrate 2 HD video on the standard base is 3D TV format. Well, again, by putting both together and using the typical active glasses, you can see 3Ds, HDs, and that's worked pretty well.
Okay. Thank you.
As long as you can do 2 video, more video, then it's just a matter to do one.
How extensible are you with respect to more identity providers, like more SAML2-based identification schemes?
For the identification, you mean the shibboleth type?
Yeah. Shibboleth type. Do you have plans for more?
Yeah, so we did a full integration with the U-portal. That's what is actually running on UPMC. We're using the CAS authentications. We just finished the shibboleth there. We can easily do more. That's and we do LDAP obviously, which is the default one, on request. That for sure, if it makes sense. But yeah.
Thank you.
Thank you very much for this interesting
Thank
presentation. I would like now to invite Michal Krysek, the researcher from CESNET, and he will tell us the presentation, use of high-speed photonic networks for effective use of very high-quality media production.
Hello. Please excuse I am not using any words like cloud or price or product. I wanted to be more general as I see that Frank is behind me and we are doing stuff together. So I think he will be more specific as I saw his presentation. Many of you may face why National Research Network should support video transmission, just because it costs very high quality, cost significant amount of money, and main drivers seems to be somehow a bit far away from classical national research customers like high energy physics. They are somehow integrated with us, but people who do high quality video, they are not that close. So I have prepared some arguments for you to face such as questions. So what's the current status of National Research Network today? So we have typically fiber optic based infrastructure. Most of us are loaning these fibers, but we have access to layer 0. We have WDM or course WDM over this fiber to get lambdas and trying to do some analog-like circuits over these lambdas. Over that we typically use Ethernet or SDH. We run IP. Most of us see IPv6 as a commodity. And the typical speed is 1 or more 10 gigabit Ethernet IP traffic flows or something like that. And utilization of this network is average for the whole network. Average utilization is below 1%. I'm saying for whole capacity. I'm not counting only the IP traffic levels, but all your lambdas. If you count all the traffic, you will be more or less in ones of percent in average, maybe a bit lower. Go. Okay, what are plans for tomorrow? Oh. We are going to the 100 gig interfaces. We are looking for more lambdas, and we are looking for better interconnection below IPv6 layers on all border interfaces. It means organizations like Glyph or Gian 3, 4, 5, whatever. But also better interconnection with university and metropolitan networks. So the capacity is growing, and what's the result? For now, seems like utilization is gonna be below 1 per mile or 1/10 of per mile or less. So is this the goal that national research networks wanna reach? So this seems a bit curious, just because we are here to support our communities and make them happier with budget we are getting. So if we are looking on this like a procurement, the best goal is to run the network cheap, as you can, satisfying all needs of your users. So, once more, go. Yeah. So what are applications that should fill up these networks? First is web. Okay, so do you really think that Facebook or YouTube can fill up your national research network? In some countries, yes. But in general, Central and Western Europe, maybe Far East, Australia, and States, do not forget, I don't think that Facebook and YouTube are able to fill Internet 2 or Gen 3 backbone or whatever. So, okay, web is not a killing application for today. P2P. I think that if you open your gates, your users should fill up your network to some level. But the price you need to pay is how much human resources are you able to dedicate to tackle with the layers from media companies? Just because, yes, more people are saying, okay, we are sharing Debian kernel or Red Hat distribution or whatever, but the fact is that most of this content that is transferred for now is pirated films. Doesn't matter the wording, just unlawful distribution of media. So the question, you can open the gate, but the price is how much people will be solving this kind of war with legal people. Okay, another interesting applications came from past is a grid. Okay, grid is nice. It is able to fill up any network you have, but ask your grid people if they want to run one cluster which has half of computers in Amsterdam and another half in London. Their answer should be probably not on daily basis, just because if the computation is somehow dense, there is a need for intensive communication between grid nodes, and if there is a delay, the capacity of the cluster is significantly degraded. So this is also not that good. So I have two more promising applications. First one is binary data storage. It doesn't mean I have one big fat network attached storage sitting in my data center and I am able to serve people from Barcelona, for example, from Prague to Barcelona, also just because of delay. But if I am able to offer some kind of layered storage with some back-end distribution, it makes some sense. Just because I don't need every piece of data on each location, I can do some smart caching. So this is maybe one of these killing applications for high-speed networks. And another one is real-time media transfer. I am not talking about transmitting talking heads like for this conference. I am just telling about transmitting something from media production. I am talking about data visualization. I am talking about cave-to-cave transfers. All these applications need real-time transfer of high bandwidth videos. What means high bandwidth? It doesn't mean the first one. This is consumer grade HD. You know, if you buy HDV camera, the bit rate coming from that camera is like this. This is not that much. We have a professional HD TV, which is something between 20 megs to 1.5 gigs. It is significant, as we have 10 gig e-network. If I have something like 100 or 1,000 of these streams, it makes some sense to upgrade the network. Oh, I can do also stereo HD. Oh, it's the data rate is doubled. Oh, what about the 4K? It's 7.6 gigs uncompressed, depending on the frame rate. I can do this in. I can do the stereo, which is almost the same like 4K. I can do 4K. I can do 8K, and I can do some tiled display, like this one. This is a Sage system built in University of San Diego, and I think this is the previous version. And I think in Amsterdam, at Sarah, they have similar wall. I think in UCSD and in Chicago, they have a much bigger display. And what's the difference between this setup and setup for desktop video conference is that you can work, you can collaborate in a team. This is not talk between 2 or 3 or 6 heads, but this is a shared workspace between groups. So this is a significant move forward for some special applications like geography, like traffic modulation, like other applications like media production. You may argue that there are some. This is not consistent just because of frames of the monitors, but this is just a question of asking some vendor to provide LCD panels without frames. Then you will have a flat screen. Oops. So let's go to the organization that supports such as applications. The application is called Cinegrid. This is California-based non-profit international membership organization, and in a very shortcut speaking, this organization wants to connect people from various areas of networking, visualization, media, hardware, software vendors to work together to create the network workspace to work for the research, but also for non-research applications. So this is Cinegrid. As I told you that Cinegrid members are NRN and networking organizations, hardware software vendors, academic institutions, research institutions, studios, post-production companies. And what we have for now is we have something like three flavors of applications. The first one is Cinegrid Exchange, which is some kind of proof of concept for long-term archiving and preservation of media material. And this is storage distributed on North America, Asia, and Europe. There are nodes, and these nodes have replicated content, and we can access this content and work with this. What we are working on is mainly to find the procedures how to preserve these data to avoid some environmental large-scale problem like tsunami. So, for example, we have one node in Tokyo, another one in San Diego, the third one in Amsterdam. So, if all these locations gets flooded, we still have Cinegrid node in the Czech Republic, and you may see there is no sea around the Czech Republic, so tsunami risk is not that high. So this is the approach we are looking for. We are also doing some demonstrations, like for this event. I had a demonstration yesterday, streaming something from San Diego to here. Typically, demonstration needs dedicated connectivity from one end to another end, which at least one end is somewhere in network wilderness. This means there is no network, no own network. Yes, there is internet, but this is not network. This is some old-fashioned stuff came from 80s. So we need to build a network to the network wilderness to run a demonstration here. So this is, and the bandwidth for this demonstration is between 6 and 9 gigabits per second. And we also have some real projects. It means we have some longer-term shared workspace, and people can work on it. Typically, this is in advance for some demonstration, just because people need to share some audiovisual material. So duration for this is something like 3 to 6 months. The bandwidth is not that high like as demo support. This is between 1 and 5 gigs per second, and both ends should be in the network wilderness. It means sometimes the computing cluster, which has some specially loaded software, is not on our network, so we need to get there by fiber. So I can show you some example for SynecV demonstration last year we had. It was spread into 2 parts. The first one was in Prague, in post-production house called UPP, Universal Production Partners, and we have another part which was in San Diego, Atkinson Hall. And what we did is shared production of 3D material. So we had a kind of 3D film, and we did some kind of special corrections like camera distortion, some color grading, and other stuff. And we need a post-production system and operator sitting in Prague. This guy has been connected by video conference with a stereographer, which is a creative position, using an ordinary video conference. And the computing cluster in Prague has been connected by 10 gig E to San Diego's Atkinson Hall, which is big auditorium, and we run the 4K stream. The material itself was only 2K, so we have been able to split the main screen to 4 parts. The first one was output of the baseline system, so we have been able to see bots on the console. The right hand was a local picture of stereographer, just because stereographer has been turned back to the auditorium, just because he wanted to see what's really happened on the screen. We have the third one, which was Face or talking head, the operator from Prague. It was here. And the fourth one, we had a smaller silver screen, and we projected the exit of or output in 3D. So in this special case, we created something like one uncompressed stereo signal going from Prague all the way to San Diego, and the total bandwidth was something like 2.6 gigabits per second, and everything was uncompressed, just because we really needed to sustain the high quality, just because if you are doing some kind of color grading, means color manipulation, it is hard to do this if you are losing some information, like if you are missing the color, something like 1 or 2 bits of color, it is hard to do. Some color grading, just because it is not possible. This is the movements in the color space are very low. So I think I am at the very end, and I hope I am on time.
Thank you very much for these presentations. Are there any questions?
What would be the cost to install such a system, multiple screens on each of the nodes? I mean, you have an idea or an estimate?
Good. Let me find this. So, typically, you need a 4K screen and a 4K beamer, which costs something like $60,000 US, I think. But if you are post-production and you are doing this stuff, it is you have this. The other problem is to get a fiber connection to the network, which depends on your locality, and then you need a computing cluster, which is also a bit costly. And the last one is to have this kind of box, and maybe this MVTP boxes or other uncompressed connection. And in 2K you can use a PC with some card, which is something like $2,000 US, I think, or you need to use some kind of special appliance. I think we have some of them here. I'm not sure, somewhere in the back. They are in prototype, and there is no final pricing yet. It will be something between $10 and $20K, I think. But don't catch my word. This is just expectation. But you can if this network is not Ethernet, if it is SDH, you can use another gear which is SDH based, and the price is between 20K to 40K, I think. The price is shifting as the developments are going easier. So it is nothing like low price. But the mission is that for guys who are doing post-production, the price for the human work and effectiveness is much better than it's much higher than the cost for such as things.
Well, your argument is that that the people providing bandwidth, they need to start working with it extreme quality video to be able to fill up their pipes and show that their investments are necessary. And how is this message received? Because I'm sure you talk about people. Is this the way that people think it will go, or will it be 1.0% of the network capacity?
Yeah, it hardly depends on time and exact perception, And I would say that when national research networks are planning some significant upgrade, they are more likely hearing arguments like this. Just because in between, it's very hard to tell them, okay guys, we would like to have a camera or beamer. And their answer is, oh, we are a network. Why cameras? Why beamers? Why something else? But there are two ways how to do stuff. The first one, you need to buy everything, so it is costly. Another barrier another way has also a barrier. You need to collaborate with the commercials, with that guys on the other end evil guys who are making money, which you are profiting from just because they are paying some taxes, or we are, to be frank, we are profiting from this paradigm. You need to work closely with them, and then you get access to devices you need. Some of them, like those beamers, as you see there, are not easy to move. But for example, some cameras, some access to the computing clusters, it's very easy to get if they are not used for commercial work. And sometimes they are arguing that utilization is over 100%, but this is not true in longer term time scale. And for example, one of the applications we are working on with Czech Post Productions is to allow users from film faculty in Prague to access these computing clusters in commercial post-production. Just because you can easily imagine that this computing cluster costs a lot of money, and this console costs, yes, significant amount of money, but something like 1% of that. So what happens if I have one of these consoles at film faculty, and they are able to use our high-speed network to access the cluster for some data which are not used for the normal production in off-peak time, which is between morning and noon, just because no one from film works between morning and noon. So we can easily utilize our network using some third-party systems, like post-production systems. So I'm pretty sure if you are creative, you will find another kind of different scenarios. Be creative, just because if you aren't, you get nothing.
Any other questions? Thank you very much once more for this interesting presentation. And our last presentation for today in this session will be Cinegrid Amsterdam, presented by Frank Kressin, who is research director at the Independent Media Lab, VAC Society, that was established in Amsterdam in 1994 and develops creative technology for social innovations.
Thank you. Thank you for your introduction. And also thank you for your talk, Michael, because I hope what I'm about to say fits quite nicely with what you've been trying to achieve, more use of the bandwidth. I made this presentation together with Kees de Laat and Walter van Dijk. Kees you saw on the main podium this morning. Kees is the chairman of the consortium, Cinegrid Consortium in the Netherlands. And I'm a co-director of a part of it, so I'm happy to talk to you about it. Please feel free to ask any questions in between as well, because we have ample time, I think. I see some of the partners of Cinegrid. Maybe you could raise your hand, so maybe you know who you are. There is Sarah as well, there is SurfNet, and we have the University of Amsterdam. So there's a lot of perspectives that we can talk about for Cinegrid. This is fairly simple after what you've seen so far. Cinegrid is about the production, transmission, and screening of sound and video in ultra high quality. And who of you has seen 4K himself? Who has seen the 4K format? 1, 2, 3. It's more than half, so you know what almost half, so you know what I'm talking about. And I hope you agree with me that it's a rather vivid experience, and when you compare it to HD or SD, you're really seeing something different. Apart from these technical things, like the 4K resolution and the 8 gigabits that Michael talked about per second, it's also, and it's mostly even this worldwide community of people from very different backgrounds who collaborate together. And we think, and they think, it's a very promising medium. And one way to show this is look just at what business these evil money-making people that we just heard about are doing with it. Actually, they think it's a very interesting technology. And they are very quickly changing their old projectors, both analog and more digital. They're changing that into the 4K domain. And within America alone, this is about 12,000 screens and counting quickly, counting up. And in the Netherlands, there are more and more. I'm sure also in Prague and in this part of the world, there are more and more people using 4K. So they really think it's interesting, and they think so either because it gives a better experience to the people sitting in the cinema. When everybody at home has HD, then you need to give something more vivid to people to entice them to come to the cinema anyway. And it also costs, it's a lot of money less that they have to spend when they don't have to spend the analog rolls of film going to the cinemas, but then again have the signal directly into their streaming projection rooms. We've seen the RED camera coming up, and it used to be very difficult to produce 4K material until a few years ago. And now there's rather cheap cameras at affordable prices that you can use to produce your 4K material yourself. And these cameras have a massive uptake. You can say literally hundreds of them are spread around the world, and it allows you to make this very beautiful material very simply. The same holds for post-production. You might use base light systems, but you also might use your own PC if it's connected to the right backend material. And it's getting more and more easy to edit the material that you've made. The same holds for viewing, although that's maybe the biggest bottleneck so far. So there are more cheaper viewing options coming up, but the ones like you see in the back of the room are still very expensive, especially when you want to have 3D. Lastly, there's a lot of content. People in the Hollywood is using 4K as a native resolution because it allows them to do editing and especially animations at a very high quality. And as you know, Hollywood only wants to work with the very best quality available, and they have the resources to do so. Just to give you an idea, for the other half of you, in the right bottom corner, you see the standard definition being rather small, high definition that you're more and more used to in your own offices and in your own homes, and then the 4K resolution, which is significantly bigger. And it's even 4 times the resolution currently used in the most digital cinemas so far. What I need to mention is that it's not just about video, it's also about the audio, because 4K, this new standard, allows you to give 16 channels of uncompressed audio with it to allow for a very high quality of audio reception. So this brings us to Cinegrid Amsterdam. And Cinegrid Amsterdam is a consortium of 11 parties who want to research and bring this project and bring this interesting technology to people who could not normally afford it, and to research the parts that are still hard, like networking, like the using of the clouds to do archiving, like just-in-time high-speed light paths between different locations to be able to use resource pooling and to use a projector in one place, a camera in another, and the storage in yet another. And we want to build a set of Lego blocks, and the Lego blocks will allow you to make your own 4K solution easily and cheaply. And within our project, we want to give this ecosystem of solutions to SMEs and to artists and to people who might use it to allow them to do what they do best, is make content and think about creative applications for this technology. Yeah. These are the partners for the consortium. There are 11 in total. On the left hand, you see the ones who started the consortium, and it's the Film and Television Academy, SARA, Surfnet, University of Amsterdam, and Waag Society, my own institution. And then there are 6 others, and if you show them like this, then there starts to come some structure into the place. On top, you see the creative and cultural parties. They're used to give meaning to technology by way of making pictures, making experiments, making games, making many things that you could see as cultural products. And I think we need them and we need those to be able to know what to do with this kind of technology. On the left-hand downside, you see 3 parties who are into the commercial aspects. Somehow we need new business models. People need to find out how to make money with this technology. And for me, being from a research institute and also some of the other partners, this is the hard part because we typically don't think about this. And within our consortium are a few parties who have this as their standard capability. Then there is SARA, Surfnet, and the University of Amsterdam, who are the research partners. And like Kees said this morning, there are a lot of things to be researched in this new field. So we are very happy to have them on board as well. And together they make up a very potent trio to come up with several challenges and goals. And the goal on the one hand is research, development, production, and showing of this high-quality digital media. We think that seeing is believing, and you need to be in contact with it to be able to know what to do. It's the exchange of knowledge. That's why we're here, and that's why we collaborate also with people from the Czech Republic, but also with America and Japan, people from very different kinds of institutions, to be able to have a very rich pool of knowledge that we can share. Then we try to develop these business models and especially entice people to come up with new ventures based on this. The content that we look for is very rich and very broad. Actually, we look for any kind of content that you could make because we firmly believe that it's not just about these pixels, but it necessitates new camera, the new placement of cameras, new lighting, new kind of makeup, you really have to rethink what you mean by making video, or making real-time video, or making a game. And we want to come up with this playing ground, this playing field, where people can experience with it, and they share their results. We did so from 2007. Maybe some of you have seen the Era la Notte performance, which was an audio performance in the Holland Festival. And it was the first 4K performance filming together with Keio University and the University of Amsterdam and all our partners. And the reason that Keio in Japan came to Holland is that they found it was the only place at that time where they could arrange the rights. Because the subject was brought up, people owning content, they have a very hard, the rights management is very, very difficult. And because we have all these partners in our consortium, it turned out that we could actually arrange to get the rights for this, to capture this screening in 4K, and it has gone around the world a lot. When the director of the Holland Festival then saw this material, he was enlightened and said, well, the quality is so high that I can really sell new tickets for this content. And that is, of course, something that they really want. This is a different example. This is a creative person, Jaap Drupsteen, who made a lot of audiovisual material. And when he saw this, he wanted to work with it, and he made small pieces. And this was a time when we approached artists to come work with us. And then suddenly it changed, and a person came to us that wanted to work with Cinegrid and with us, in the form of Maarten de Heer, who made this panorama. It's typically Dutch panorama. So everybody who has been to Holland might attest to. And the things you might see here are so small that it's this single image and captures probably tens and maybe even 100 different stories. You have to imagine that everything that's animated is about this big and this rich in detail. And within on the big screen, you see hundreds of small characters doing things like this. And you can see this piece all over again. It's about 10 minutes. You can see it all over again, and each time see a new part of the story. And that's, I think, one part of cinema that would be hard to attain with conventional media. We have Red Ant, and Red Ant was a stop-motion animation. It turned out that when you are a stop-motion animator, it's relatively easy to make stop-motion 4K movies. And they did so in incredibly rich detail. They worked for 1.5 years, doing 3 days a week, a few seconds of their film based with these stop-motion characters, and the result is actually stunning. And what the filmmakers told us is that 4K allows them to look at the film and then forget about this camera, so forget about the medium that is in between the shot that they were filming and the projection, the eventual projection. So it really brings them back to the moment that they shot it. And I thought it was a very large compliment for this media. And this was also shown by Kees. I want to show it once more because we are very proud of it in our consortium. It's in 2010, so almost a year ago, we did another recording with the Holland Festival, but now in 3D. So we have all this material, and we'll put it in the Cinegrid Exchange for people who know how to project it, and then look at the way that using 3D necessitates different camera angles and different shots and different zooming as well, because that's what we want to find out. Cinegrid Amsterdam has 6 work packages or 6 strands. One is building a center of excellence. The other is doing research into these Lego blocks, and Ralph might tell you more about that. We produce a lot of content. I just showed you a small part of what we did, but we have filled a lot of this Cinegrid Exchange with Dutch material. We do a lot in education. Together with Surfnet, for example, and the Film Academy. And we work into these business cases I already told you. So all of these things are within a 3-year program that started in 2010, and it will be till the end of 2012. So we have a lot to do. Last month, we opened this small-scale Cinegrid production studio. It's in our building, and it has a 4K screen, some 4K workstations, the cards that were already mentioned and allow for a relatively cheap way to produce this content. And it is open at this moment 2 days a week for artists to come and work with us. And if they want more, then we have to work with them to see how we can do it. But it will be open for at least 1.5 years. And if you would work in Amsterdam, I would be very happy if you would join us and work with us in that. Of course, there is a website, which unfortunately for most of you is in Dutch. But it shows everything we do, and we try to document it in a way that other people can benefit from this. And we foster a lot of hands-on collaboration. I started with this message that to be able to make use of a new technology in a meaningful way, you need to put people together that would not normally be together, I think. And I think about the artists themselves, the technicians, the scientists, the people from the different cinema, people from the funding agencies. And typically when you put these people together, they might have a hard time collaborating. And a large part of what our society, as my institution, does is try to see that this engagement, the talks that go on, that they are put on in a way that is beneficial to all of the participants. And based on these dialogues, we are able to make a lot of new material and document the way it's being done. Last part I wanted to talk to you is the educational challenge. We think the education, when we started Cinegrid, we were thinking that educational use would be promising. But it didn't start just by itself. It needs some different incentive to be able to have people really work with it, think about it, make material, show it, try it out. And that's why Surfnet and Kennisnet and Waag Society thought about making a contest, which is a very simple form of engagement, in which we asked people or stimulated them to come up with educational uses. When they entered the competition, they had to fill out a form and they could say what they want to make. And then they got access to a 4K production set, technical and artistic assistance, and 5K in cash, because making a conventional production is a little bit cheaper than making a 4K production. And based on this, we had a lot of contestants, and over the 2 years, we have 10 winners, and they made their material. So for the 2010, we had very different kinds of people. These 5 winners, what they have in common, obviously, is that they were looking for usages of images in very high resolutions. So being able to show things for either research or education that you could not or could hardly see without this resolution. And this one I want to point out. It's called Larger Than Life, a title that holds its name, I think, because what you see here is on the right side a projection of a person talking to you, and on the left side you see a wooden frame with an actual person in it, the same person, of course. And Larger Than Life is research into perception, and the professor doing this research set out came with the idea that things might be too sharp, and by having a too sharp image, it would make you go away instead of approach it more. So it's a very researchy experiment that people from the cultural sector would never have done, I think. He made this frame, the professor made this frame by hand exactly to match the frame of the screen, the 4K screen that we have. The research was carried out end of last year, and now they're collecting the results and writing it into a scientific paper. And I'm very curious what will come out, because it will be devastating, of course, if things could be too sharp for the strange idea. Then, of course, to be able to share what is learned, we made a 4K cookbook that will be expanded as we have new experiments coming up. It's translated in English, and you can download it from the website of SurfNet. We try to pool everything that's learned regarding both the technical and the artistic side into this research, extend it and share it, and so other people can learn from it and contribute. Of course, there's a lot of future directions that we are looking into. Some of the contestants from the new contest, they already started diving into these topics, so I'm sure that before long we will have new results. And meanwhile, we are working on our Lego blocks entry-level 4K system to allow a greater uptake of this kind of technology and the artistic use of it. These are the people who are behind the 5 main partners. The pictures I should mention are by Arne de Laat that I just showed, and Arne, he is the son of Kees de Laat, and he's a good photographer, I think. And if you have any questions, please let me know. Answers?
I would like to ask about the studio. Is it only for post-production or for recording, and what equipment you have?
It's for post-production and streaming, and we have a local storage set. We have how's it called? An on-demand light path. There we have a screen, and we have some computers with editing software. So it's just for the post-production of the material. And we do this because the 4K, well, if you want to produce 4K, you can do it either by using, for example, photo cameras or just animation. And if you really want to work with live images, then the options for renting cameras are increasing all the time. And because we are a publicly funded project, we don't want to compete with the people who are already doing this. So we work together with them, and we just concentrate on the niche that is there. Post-producting, so the end post-product, so just before you show it, and then showing it to either directors or small audiences, so they can really see what is the quality of the material and if it's good enough.
Okay, thank you.
And I have a list of the technology. I could send it to you.
So Frank, if you have post-production, is there any kind of partnering, commercial post-production people can work with? Means I have my data located on the other side of Amsterdam, and I want to go to your facility and work with these data?
Well, this is what we envision. We just opened up in April, and now there are people going out to the different production companies to show them what we have and entice them to come in, and then we will have package deals. Because this is obviously the way to go. And we will never have a baseline system because that is not in our interest. Our interest is in making this screening and the last part accessible. So we will partner with anybody who has those.
Okay, thank you.
Are there any other questions? Yes, thank you very much for this presentation. Okay, this was our last presentation in this session. Thank you for presentations. Thank you for attending this session. And I would like to remind you once more about demonstrations, posters, BOFs, and workshop. Thank you very much.